So we're going to look at 4.2, which is simplifying with the radicals. So when you're simplifying with radicals, when you're multiplying two things with radicals in them, such as square root of x times square root of x, you already remember that that would be the same as combining both these in the middle. So obviously when you circle a pair, the square root of this, you can pull out any pair. So the square root of this would end up just being x. Okay, and that's a rule you can sort of follow. For example, square root of 7 times square root of 7 is 7. Square root of pi times square root of pi is pi. So anytime you're multiplying the same thing under here, what you're going to end up getting is just x, 7, or pi. Even works with an expression. Say you have an expression such as x plus 3. Well, as long as they're both the same, okay, it's really the square root of x plus 3 and x plus 3. So since I have two of them, this would equal x plus 3. All right, what's going to be new now, and you've done this before, but we're going to look at something special, okay? And square root of x plus 2 and square root of x minus 2. We want to look at what does that end up being when we multiply it out. And yes, you are going to have to FOIL that. You can use your box method or however you use to multiply. Here's what I would do with the box method. Is I would have square root of x plus 2 here, square root of x minus 2 here. And when I multiply these out, square root of x times square root of x is x. This would end up being negative 2 square root of x. This here would be 2 times square root of x. And 2 times negative 2 is negative 4. So when we multiply these together now, what we end up with is x minus 2 square root of x plus 2 square root of x minus 4. And what makes this a special situation is you'll notice these are going to be opposite of each other and they're going to cancel out. So these actually cancel and end up with x minus 4. So there is no more radical in this. They end up actually all canceling out. Now why this is special is we call these these are conjugates. And what makes them conjugates is when you multiply them together, they eliminate this radical. So if you want to know what a conjugate is, anytime you have square root of a plus b, it's conjugate, all you do is you switch this sign. So it would be square root of a minus b. Or in this case, let's say you have square root of a minus b, well, its conjugate would be square root of a plus b. Only change this sign. Some people want to change both, okay, but that's not the case. So let's look down here at number 6. Okay, what would the conjugate be for 6? So this is square root of x minus 3. Well, the conjugate would be square root of x plus 3. So if I asked you to multiply these, you could do this box method, but what would happen is you'd end up with 3 square root of x, negative 3 square root of x would cancel out. So what you want to really recognize is your resulting is going to be x, and then it's always going to be a minus, and then whatever these two multiply to be, which in this case is 9. So that's sort of a simple way of multiplying the conjugates. So really it's this, whatever's under here, okay, square root of x, you really just square this, and you square in this, and you put a minus between it. So, all right, you should be able to go on and do practice 4.2.